High concentration sulfuric acid can easily be found at very affordable prices in hardware stores. I use the Zepp brand stuff, which is around 93 to 94% sulfuric acid. However, there is one issue. These products always contain some sort of stabilizers and agents meant to protect piping in your home. The Zepp stuff looks a lot like red cherry syrup and is obviously not good for chemical reactions. This video was originally intended to report on the distillation of sulfuric acid from drain cleaner. Distillation is the best, common method to purify sulfuric acid because very little acid is lost in the process, and measures can be taken to safely contain extremely hot, dangerous acid spills and vapor. I do not own a heating mantle, so I tried to use a sand bath to perform this. However, it wasn't able to reach the 300 plus degrees Celsius needed to boil sulfuric acid. So instead, I will be demonstrating the cheapest, easiest method of purifying sulfuric acid drain cleaner. Hot acids are extremely corrosive and will char tissue instantly if it gets the chance. This process gives off lots of hazardous fumes that can and will cause coughing and irritation in the eyes. I have a homemade fume hood, but chose to conduct this experiment outside with a fan blowing away fumes and basic solution for neutralizing spills nearby. This really is quite dangerous, and I would only recommend recreating this procedure with proper safety equipment, prior lab experience, and meticulous research in case of emergencies. A 2,000 milliliter Erlenmeyer was filled with roughly 500 milliliters of sulfuric acid drain cleaner and heated at full blast with the cheapest hot plate Walmart offers. As the solution heats up, the corrosive properties of the acid become more intense. At around 300 degrees Celsius, this should be enough to break down any organic stabilizers into CO2, which will escape the container. I had to go to dinner, so I took the flask off the heat. You can see the colors change from red to a slight yellow. I then added a small amount of hydrogen peroxide, which theoretically reacts to form another acid, which will help break down any stabilizers and is converted back to water and sulfuric acid when heated. I really do not think this was necessary. Adding water to acid is a big no-no, and there's a good chance the heat just destroyed all the peroxide before it could react. The heating will also cause a dehydration of the solution. Water evaporates, increasing the concentration of the acid until an azeotrope of 98% sulfuric acid is reached. At this point, the concentration will stop increasing. Despite using broken glass boiling chips, sulfuric acid is infamous for boiling extremely aggressively at high concentration. I let it do this for about 10 minutes and then decided for safety that it was probably good to go. Bringing it inside, you can now tell it appears to be completely clear. The next day, I transferred it to a beaker and concluded that, accounting for water loss, only about 60 milliliters of sulfuric acid was lost. By measuring the density, temperature, and referring to a concentration chart, I found the product to be somewhere between 95 and 98%, likely leaning closer to the higher number. This was then transferred to a PTFE container. Strong acid can only be stored in chemically resistant plastics or glass bottles and in a dark, cool environment. Thank you for watching. Please like and subscribe for more chemistry content.